Group 3 ready? Baru-baru start record tu yang cakap balik tu. Group 3 boleh present sekarang.
Boleh dengar tak suara?
Oh, boleh. Merdu. Siapa tu? Munir ke?
Ya.
Oh, macam artis
Okay,
lah bunyi. Silakan.
Assalamualaikum warahmatullahi wabarakatuh and good morning to Dr. Faizan and my friends. Today, we are from Group T. We will be presenting about the analysis of trace elements, copper, cadmium, and zinc in the muscle, gill, and liver tissues of some species using analytic stripping voltammetry.
Okay, for the type of voltammetry used is analytic stripping voltammetry. This method was used to demonstrate the presence of multiple metal in sample. The advantage of this method is this technique lies in its ability to trace and auto-trace level analysis. Next. This method involving two steps, predeposition step and stripping step. Next. Okay. Type of electrode used is hanging mercury drop electrode (HMDE), which is the variation of DME. As a working electrode, where the electrochemical reaction occurs and where the analytical signal is generated. Next. Okay. Silver chloride was used as a reference electrode. The electrode function as a redox electrode and the equilibrium is between the silver electrode. Selamat Lim. The electrode function as a redox electrode and the equilibrium is between the silver metal and its salt silver chloride. And it's offers stable half cell potential that do not change over time and or with temperature. The corresponding half fraction can be presented as follows. Next. Okay.
Okay, for the sample study, we studied the muscle, gill, and liver tissue in those fish, which is Otolithus rubber, Pampus argentus yang kita tahu sebagai bawang putih, Oncorhynchus mycis salmon, Parastromatus niger, and Scomberus commerson mackerel.
Okay, highlight analysis. In this journal, the analysis of heavy metal, copper, cadmium, and zinc from different tissues, muscle, gill, and liver of fish species, just like listed by Sabrina just now, using ASV technique. Copper is essential for the normal metabolism of fish, and it must be taken up from water, food, or sediment. And zinc is included in the list of elements in which their psychological role and necessity for plant life is already being proved. And cadmium level can be particularly elevated in the kidneys of marine mammals, and cadmium could be stored over a very long time in the renal tissue of marine mammals. Okay, next. Okay, as we know, cadmium element is a toxic element, and its potential toxic effect can be reduced by binding to the metallothionein. Here, as we can see, the metallothioneins bind to the cadmium metal via sialate bonds and form a cluster. As a result, the toxic effect is reduced. Okay, next.
Okay, next is concentration of analyte. Based on the result, the analyte concentration obtained is in ppm. This research also obtained there is a low level of detection limit, and the concentration range for each analyte are within for copper it lies between 0.44 to 0.05 microgram per gram, and for cadmium 0.585 to 0.001 microgram per gram, and for zinc is 0.45 to 0.05 microgram per gram. Okay, next.
Okay, as for the results of this study, in table 1, it shows the determination of copper, cadmium, and zinc in the muscle, gill, and liver of O rubber. As you can see, there is no copper detected in the liver tissue of the O rubber species, and zinc level in the muscle tissue of O rubber was higher than the gill and liver tissue of this marine organism. Also, the maximum concentration of cadmium was found in the gill tissue with 0.086 microgram per gram. Next. So for the table 2, determination in P. argenteus. So the maximum concentration of zinc was found in the muscle tissue with 0.25 microgram per gram compared with gill and liver tissue. And there are no significant difference in the concentration of cadmium in this species. Whereas, as you can see, muscle with 0.06 microgram per gram, gill with 0.04 microgram per gram, and liver with 0.005 microgram per gram. And as for table 3, determination in P. niger, the maximum concentration of copper, cadmium, and zinc was found in the liver tissue with 0.009 microgram per gram, 0.585 microgram per gram for cadmium concentration, and 0.45 microgram per gram in zinc. And there is no copper detected in the muscle and gill tissue of P. niger. Next. For table 4, it shows the determination in S. commerson. The maximum concentration of copper in the liver tissue with 0.057 microgram per gram, and the highest zinc content was found in the gill tissue with 0.062 microgram per gram. For the table 5, determination of in the Omyces species, by comparing of these three marine organisms, Omyces displayed the highest copper level in muscle, gill, and liver tissue with 0.44, 0.044, 0.34, and 0.23 in the muscle. Also, the cadmium of this organism was the lowest, with in the muscle tissue, it shows 0.001 microgram per gram, 0.004 microgram per gram in the gill tissue, and in the liver tissue, 0.02 microgram per gram. Next. So the result of this study shows that the copper concentration reached the maximum in the liver Omyces with 0.44 microgram per gram, and followed by the liver of O rubber and the muscle and gill of P. niger, which is not detected. Cadmium content reaches to maximum in the liver of P. niger with 0.585 microgram per gram, and followed by the muscle of Omyces with 0.01 microgram per gram. Zinc concentration is the highest in the liver of P. niger with 0.45 microgram per gram, and followed by the muscle of S. commerson, 0.005 microgram per gram. Balik previous. And the results show that the concentration of copper, cadmium, and zinc varied between 0.44 and not detected, 0.585 and 0.01, and 0.45 and 0.005 microgram respectively. So copper, cadmium, and zinc levels were obtained in this study. The result of this study indicate that the concentration of copper, cadmium, and zinc is significantly lower than the permissible limit set by WHO 1972. Okay.
Okay, for the conclusions, anodic stripping voltammetry method was applied to the determination of copper, cadmium, and zinc in the different tissues, muscle, gill, and liver of O rubber, P. argenteus, P. niger, S. commerson, and Omyces. The concentration of copper reaches to maximum in the liver of Omyces, 0.44 microgram per gram, and followed by the liver of O rubber and the muscle and gill of P niges, which is not detected. Cadmium content reaches to the maximum in the liver of P niges, followed by the muscle of O micis, 0.001 microgram per gram. Next. The concentration of zinc is highest in the liver of P niger, 0.45 microgram per gram, and followed by the muscle of S. commerson, 0.005 microgram per gram. The content of heavy metal in the fish species is well below the permissible levels. That's all from us. Thank you.
Okay, thank you to group 3. Okay. Okay, untuk semua presentation kita tengok macam-macam application untuk voltammetry kan. Okay, group 3 tadi microgram per gram tu apa? ppb ke ppm? Soalan saya. Aja je nak test. What is microgram per gram? ppb or ppm?
ppm.
ppm. Okay. Alright. Group 1 hari tu pasal paracetamol kan? PCM kan? Betul tak? Group 1 paracetamol. Lupa dah. Panadol analysis tu. Group 1 pasal apa? Group 1? Hello?
Betul lah, group 1 pasal paracetamol.
Okay, group 2?
Group 2, vitamin B6.
Cah ni wakil semua group ke Cah ni? Saya nak dengar group 2 sendiri cakap mana group 2.
Saya lah group 2 tu.
Group 1 tu apa? Tak cakap tadi. Group 1 tu nak cakap Group 2 pasal apa? Vitamin C.
B6.
B6. Okay, group 3?
Heavy metal.
Heavy metal. Group 4? Group 4. Suspicious saya. Korang ni sebenarnya buka kelas lepas tu buat benda lain Siapa tak nak menjawab ni? Group 4 dan group 4?
Pasal mercury.
Mercury. Group 5 tadi pasal? Group 3 tadi pula. Group 5 hari tu pasal? Analyte apa? Analyte.
Epinephrine and norepinephrine.
Okay, so tengok kita boleh detect inorganic ataupun organic analyte menggunakan voltammetry. Itu kelebihan voltammetry. Okay. So based on that 5 journal tu, saya akan buat satu quiz next week. Okay. Hari apa quiz kita?
Khamis.
Khamis. Hari Isnin kita nak buat apa Revision. Okay, good. Alright, kita tengok balik soalan test hari tu. Mana pula sharing ni? Okay. Soalan test. Soalan pertama. Briefly explain the history of the polarography and voltammetry. Okay, yang ni, mau jawab apa ni? Jawab pasal pakcik ni tak? Sekejap saya share. Korang jawab pasal pakcik ni tak?
Betul.
Chemist Jaroslav Heirovsky in the 1922 received the Nobel Prize in Chemistry for this work. Okay. They enhance enhance sensitivity and expand the application of analytical method, introduce low cost operational amplifier. Okay, basically basic thing pasal voltammetry, polarigraphy ni, pakcik ni. Okay, Jaroslav Herovsky ni. Korang jawab pasal dia tak?
Jawab.
Jawab ya. Okay, draw and label the schematic diagram of voltammetry measurement setup. Ini korang jawab apa? Jawab tak? Lebih kurang macam ni.
Jawab.
Betul, jawab.
Okay. Kita ada apa? Ada working electrode. AE apa? Auxiliary electrode. Okay. G ni apa G ni? Galvanometer. Okay, potentiometer ataupun potentiostat kita panggil. Dan juga apa benda ni? Ada plus minus ni. Voltage source. Okay. Alright, itu schematic dia. Macam tu je. Describe about the electrodes available in the voltammetry cell. Korang perasan tak markah dia berapa tu? Markah berapa soalan 3 ni? 10. So, kalau kau sebut je 3 je electrode tentu macam tu je, tak cukup. Kena explain. Okay. Working electrode ni untuk apa? Reference electrode ni untuk apa? Okay. Counter electrode ataupun dipanggil sebagai apa? Auxiliary electrode ni. Okay, sebagai apa? Biasanya material dia apa? Okay, so kalau explain detail tu, okay, describe about the electrodes, dapatlah 10 markah. Okay, draw and label the multi-mode electrode MME setup. Ini yang mana? Multi-mode mana? Multi-mode. Okay, ni. Okay, berapa markah dia soalan tu? 5 markah. Okay, at least korang lukis dan ada label dia. Mercury, needle, taper, capillary, Hg drop. Dapat 5 markah. Okay. State the difference between drop mercury electrode DME and static mercury drop electrode SMDE. Apa beza dia? Apa beza DME dengan SMDE? Anyone? Saya nak tanya siapa Zam lah Zam. Zam, come on. Apa beza DME dan SMDE?
Apa beza?
Jawab apa itu? DME dan SMDE.
SMDE static. Lepas tu saya differentkan graph.
Okay. DME keep on dropping kan?
DME drop, keep on dropping.
Okay, dan dia akan jatuh based on gravity kan?
Yes. Apa tu size dia? Size dropping
okay.
dengan static different. Sebab kalau dropping dia akan start untuk daripada small to large, lepas tu baru dia drop. Kalau
Okay, dan kalau SMDE dia control kan?
Dia punya size dia kita control.
Alright, good. Okay, Zam sambung lagi. The purpose of supporting electrolyte.
Kita nak elakkan, kita nak tingkatkan sensitivity dalam analyte tu. Tapi kita takkan kacau dekat reference electrode.
The supporting electrolyte ni, dia tak akan mengganggu working electrode kan? Tak akan mengganggu analisis. Cuma dia meningkatkan apa? Sensitivity. Okay. Yes. Macam mana cara dia tingkatkan sensitivity?
Unit tu doktor.
Okay, ni saya nak tanya Chu Zin Yi. Macam mana supporting electrolyte meningkatkan sensitivity? Chu Zin Yi. Chu, come on Chu. How does the supporting electrolyte increase the sensitivity macam Zam cakap tadi? Chu Zin Yi. Mic rosak ke? Okeylah, kita pass kepada Farah Amirah. Farah Amirah, macam mana supporting electrolyte meningkatkan sensitivity? Farah Amirah. Tak best ni cakap satu orang ni. Kemana korang ni? Nampak ada, tapi tak ada. Lee Chan Yu.
Yes, Doctor.
Okay, how the supporting electrolyte increase the sensitivity?
It decrease the migration of the ions so that the charge does not get what lah?
Ulang balik. Tak dengar.
It avoids the migration of the ion of analyte so that the charge does not go away. Sedia lah.
Okay, siapa nak bantu tambah? Ni slide ni saya ambil daripada korang juga tau. Okay.
Doktor, yang
saya tunjuk slide lah.
matrix tu ke?
Ha?
Yang mas
Apa, explain je macam mana sensitivity dia increase. Saya refer pada ni je, pada Zam tadi. Increase sensitivity. Saya dengar tadi yang Zam cakap. Zam nak betulkan ke macam mana? Adakah dia increase sensitivity ataupun dia increase conductivity? Siti Aifah nak cakap.
Oh, ya doktor. Oh tak.
Zam tak dengar Zam cakap ke tu?
Ya.
Tak dengar. Sekali lagi.
Silap maafkan saya. Bukan sensitivity, selectivity in the ion.
Selectivity. Macam mana cara dia?
Kita akan guna analyte yang sama.
Tak, sekarang ni kita
dia
cakap
macam
pasal supporting electrolyte kan? Okay. Kalau conductivity kita tahulah. Conductivity increase, okay, eliminate the transport of electroactive species by ion migration in the electric, macam Lee Chan Yu cakap tadi kan. And maintain the constant electronic strength. Okay. Dia increase conductivity sebenarnya. Okay.
Saya punya jawapan salah dah.
Dia dalam electrolyte ni dia ada chemical species yang tidak elektroaktif dan juga inert. Okay. Dia tak akan mengganggu dekat working electrode. Dan dia juga ada ionic strength dan juga conductivity yang tinggi. Tapi dia tidak. Dia beza tu. Walaupun dia ada ionic strength dan conductivity tinggi, kita punya supporting electrolyte ni dia tidak elektroaktif. Tak elektroaktif ni maksud dia tidak akan menghasilkan apa-apa peak. Tapi dia ada ionic strength dan conductivity tinggi. Dia hanya boleh menjadi konduktif sahaja. Okay. Dan dia tidak akan terlibat dalam menghasilkan apa-apa peak pada voltammogram tu. Cara dia, they eliminate the transport of electroactive species by ion migration in electric field. Itu cara dia. Right, next question ialah,
Okay, thank you, Doktor.
okay, describe the benefit of stripping voltammetry in terms of sensitivity. Macam mana? Saya nak tanya siapa ni? Jekti Iswari.
Doktor.
Okay, soalan nombor 5. Nombor 6. Describe the benefit of stripping voltammetry in terms of sensitivity.
By increasing its Faraday current.
Okay, good. Thank you. Kena explain lah. Dapatlah 5 markah tu. Bagilah ayat sikit kan. Describe the benefit of pulse voltammetry in terms of the sensitivity. Saya nak tanya, lama tak dengar suara Hanis Adibah. Hanis, mana Hanis?
Yeah.
Okay, nombor 7. Describe the benefit of pulse voltammetry in terms of sensitivity.
Sekejap Doktor.
Okay.
Electrode process excited in different ways. Betul
Macam mana? Macam mana?
Electrode process tu dia excited in different ways. Kiranya dia change the square wave potential.
Change the?
Square wave potential.
Okay, dalam OGC yang cakap pasal ni ialah siapa? Online Global Classroom. Siapa yang explain pasal ni? Pasal kelebihan pulse voltammetry.
Doktor yang laki tu.
Dr. Jose kan? Dr. Joey. Alright? Caranya Dibah macam mana tadi? Caranya Anis? Anis? Macam mana cara tadi?
Cara dia.
Macam mana pulse voltammetry? Tadi Anis baca. Cuba explain sikit.
Change square wave potential.
Dia change dekat square wave?
Potential. Dekat.
Potential. Sekejap saya buka slide Dr. Joey ni. Nak tengok mana dia cakap.
Doktor, dengan dia reduce capacitive current ke?
Anis pula tanya saya.
Tak kan?
Sekejap saya buka slide. Okay, ini yang Dr. Joey tunjuk hari tu. Okay. Improving sensitivity. Okay. Pulse method, differential pulse voltammetry, square wave voltammetry. Cara dia. Electric processes are excited in different ways with periodically changing square wave potential at a constant or increasing amplitude. So measurement towards the end of past time tu ialah Chief Faraday contribution and vanish almost current tu vanish almost completely. Okay, apa yang jawab lebih kurang yang macam Dr. Joey bagi tahu. Bolehlah markah. Okay. Lebih kurang lah yang ni cakap tadi. Alright, nombor 9. As a chemist from the Department of Environment Malaysia, you are given a task to analyze the arsenic contamination in the mining wastewater. You have decided to use voltammetry instead of other instruments. What is the benefit of the voltammetry compared with other instruments? What type of electrode will you choose for a voltammetry setup and explain the reason? Yang ni saya nak tanya Hamka. Hamka, soalan nombor 9, Hamka. Nombor 9 ni diberitahu oleh Dr. Asmat. Nombor 9 ni, soalan nombor 9. Seperti yang Dr. Asmat share.
Sekejap
Kan, apa nampak tu?
Oh. Dia nak guna apa tu? Elektrod apa ya, Doktor?
Ya, baca nombor 9 tu. Kita jawab macam mana?
Tak nampak soalan je, Doktor.
Tak nampak ke? Saya share pun kau.
Kat skrin saya ni warna kelabu.
Oh, kelabu pula dah. Okey. Soalan nombor 9.
Nampak.
Nampak?
Nampak.
Tak nampak tu petanda sebenarnya tu. Okey. Nombor 9, sebagai kemis Jabatan Alam Sekitar, kita nak analyse arsenik dalam contamination dalam air kan. Kita decide nak guna voltammetry. Okay, dan apa benefit? Soalan pertama dia, apa benefit voltammetry compare dengan ada instrumen?
Yang apa yang saya dengar daripada apa yang doktor cakap, benefit voltammetry ni dia murah sebab dia guna low, guna apa, jumlah analyte yang sikit je. Dia apa ni, dia cheap.
Okay, cheap. Then explain lah kenapa cheap.
Sebab dia guna dia guna amount of analyte dia sikit je, tak banyak. So
amount of sample sikit kan. Satu lagi kita hanya guna apa nama ni, buffer solution kita kan, pun murah preparation. Tapi sekarang ni electrode apa yang kita nak guna ni untuk setup ni? Dan explain
guna gold.
Gold kenapa?
Sebab macam mana saya nampak apa lagi. Dan ada sebab positive potential. The positive potential of arsenic. Potential of arsenic dia dalam gold electrode-nya potential window.
Okay. Dia guna gold as working electrode. Apa maksud positive potential of the working electrode? Apa maksud dia? Of the arsenic tu? Kenapa kita guna gold sebagai working electrode? Kenapa tak guna electrode lain?
Sebab dalam gold electrode dia dapat detect arsenic dengan lebih
sensitif lah kan. Maknanya dia lebih sensitivity untuk detect arsenic guna gold electrode lebih tinggi kan. So explain sikit, dapatlah markah tu. Right. So next question, explain the purpose of the electrode modification. Apa tujuan kita nak modify electrode? 10 markah. Ni nak tanya Nazila Al-Jeffrey.
Doktor.
Nida, ni ada kelas
Nak tanya
apa tadi? Okay, Nida tanya apa Nida?
Elektrod yang tepat tadi apa doktor untuk
arsenik?
Iya.
Gold.
Oh, okay.
Dia jenis elektrod dia apa? rotating disk kan?
Mm-mm.
Okay, so rotating disk yang jenis gold. Okay.
Okay.
So nombor 10. Nazila Al-Jafri, explain the purpose of the electrode modification. Kenapa kita nak modify electrode ni?
Okay,
Suka hati.
there are actually 5 purposes. First thing first is to decrease the detection of limit LOD, and then increase the electrochemical response or sensitivity, and then followed by for it to be more safer, and then we want to improve the selectivity towards the target species.
Nazila, jap. Kenapa safer? Kenapa lebih selamat?
Kejap doktor, saya cari jawapan saya sekejap. Kejap doktor.
Okay, kenapa dia lebih selamat?
Safer.
Logically kenapa? Kita modify, okay, electrode modification ni sebenarnya bila kita guna rotating disk lah kan, takkanlah kita guna mercury tu kita modify kan. Maknanya kenapa lebih selamat? Sebab kita tak guna mercury lah. Mercury kan bahaya.
Yang tulis acts as an alternative for mercury electrode.
Okay, yalah betul lah. Maknanya kita tahu mercury tu bahaya, so kita nak buat electrode modification lain instead of guna mercury kan. Macam guna apa nama ni, glassy carbon kan, macam pencil lead tu. Okay, lagi next.
That improves selectivity towards target species. Then last but not least is to increase the stability.
Okay, itulah tujuan dia. Kita nak pertama kali tujuan dia supaya kita dapat detect analyte dengan mudah. Mudah macam mana? Detection limit dia rendah kan. Kita nak decrease the LOD. And then kita nak increase the electrochemical response. Dia punya sensitivity. Kalau dia LOD dia rendah pun tapi dia tak berapa sensitif pun susah juga. Okay. Dan juga kita nak selamat, okay, tak nak guna mercury, dan kita nak improve selectivity. Apa maksud selectivity? Apa beza selectivity dengan sensitivity? Sensitivity ni dia punya kita punya electrode punya efficacy dia untuk detect tu. Okay, maknanya kita tak macam mana dia lebih mudah untuk detect. Meaning that low detection limit tu satu, dia lebih sensitif. When the analyte is present je, dia boleh detect. Okay. Alright. And then selectivity pula, maksud dia boleh bezakan analyte tu. Tak naklah apa nama ni, overlap peak tu kan. Tu tak selektif lah. Selektif meaning that boleh bezakan peak bagi setiap analyte. Dan juga stability. Kita punya electrode lebih stable kan. Kalau dalam bentuk mercury tak stable kan. So kalau dalam bentuk solid macam glassy carbon semua ni lebih stable. Okay. Right. So terima kasih Nazila Al-Jafri. Next soalan seterusnya. Describe the methods to do surface modification on solid working electrode. 5 markah. Alright. Syafiq Hazlan. Soalan nombor 11. Describe the method to do surface modification on solid working electrode. Syafiq Hazlan. Syafiq Hazlan 1. Syafiq Hazlan 2. Tak jawab lagi ni.
Ya, doktor.
Okay, nombor 11. Describe the methods to do surface modification on solid working electrode. Macam mana method dia? Jawab apa macam hari tu?
Sekejap saya cari jawapan. Saya jawab direct casting.
Okay.
And then deep coating process. dengan spin coating.
Okay, ada 3 kan. So direct casting ni kita guna kita panggil sebagai thin film coating kan, dopant. Maknanya kita dope je lah kita punya elektrod tu. Okay. And then ada deep coating. Deep coating ni kita dengan cara dipping lah. Kita immerse kita punya elektrod tu dalam modified apa nama ni? Solution yang kita nak modify elektrod kita tu, kita hanya celup dan pastikan dia dah ada layer lah dekat elektrod kita. Yang ketiga ialah spin coating ni, kita guna nanofiber. Biasanya kita guna electro spinning instrument lah untuk kita coatkan dia. Guna nanofiber yang kita dah specify nak coat untuk working electrode kita tu. So ada 3 cara biasanya. Right. So soalan seterusnya, terima kasih Syafiq. Nombor 12, explain the application of sensors development. Apa application dia? Teh Hi Hui. Soalan nombor 12.
Yes, Doctor.
Application, yeah. Number 12 tu. Explain the application of sensor development. Apa application dia?
Got the one, the small, the and wait. One of the applications is screen printed carbon electrode, the sensor.
Untuk buat sensor. Okay, good. Lagi?
Lagi itu carbon paste electrode.
Okay, untuk buat carbon paste electrode application. Alright, boleh. Lagi?
Multi-wall carbon nanotubes, the GEC.
Alright. Macam-macam lah application of sensor development ni kita boleh buat bermacam-macam jenis elektrod. Macam Teh cakap tadi kan, ada multi-wall carbon nanotube lah. Ada kita buat screen printed electrode dan sebagainya. Okay. You jawab example of application sensor development tu, dapatlah markah. Okay. So terima kasih Teh.
Thank you, Doctor.
Okay, alright. So ni ada beberapa nama saya panggil tak sahut tadi. Antaranya ialah siapa saya panggil tadi tak menjawab tadi? Ciu tak jawab saya tadi. Siapa lagi?
Tadi balas dekat Doktor. Ciu tadi balas dekat chat.
Oh, dia tak boleh pakai mic
Tak sure, tapi tadi saya tengok dia.
Oh, Ciu balas pakai chat. Okay, tak apalah, mungkin mic dia tak boleh ataupun dia berada di kawasan yang tak boleh nak on mic. Okay, tak apa. Siapa lagi saya panggil tak jawab tadi? Siapa tadi?
Semua jawab, Doktor.
Semua jawab Okay, tak apa. Semua jawab. Alright. Alright, so itulah soalan-soalan yang saya buat masa test hari tu. Semuanya berpandukan online global classroom punya slide dan talks. Okay, ada yang tak ada dalam slide pun, tapi ada dalam talk. Alright. So markah-markahnya diberikan berdasarkan apa yang kita bincangkan tadi. Okay. So nanti saya akan announce lah markah untuk test ni dan juga quiz sebelum ni. So untuk next Monday kita akan buat revision untuk final exam, dan next Thursday ialah quiz based on apa yang korang present pasal journal tadi, the application. Okay. So, itu saja untuk hari ini. Terima kasih. Ada soalan tak? Tak ada Alright. Itu saja. Attendant tadi semua dah scan ke?
Saya belum.
Okey, yang belum saya akan buka balik Alright. Terima kasih semua. Assalamualaikum. Dan bye-bye.
Thank you, Doctor.
Most welcome.
Terima kasih, Doktor.
Okey, sama-sama.
Thank you, Doctor.